Welcome to the DIY Honda Garage channel. The DTC P0792 indicates an issue with the intermediate shaft speed sensor A, circuit range, performance in the Honda Civic, specifically for models between 2011 to 2015. This diagnostic trouble code points to a malfunction occurring within the electrical circuitry associated with the sensor, rather than a mechanical fault in the transmission. The intermediate shaft speed sensor plays a crucial role in managing the continuously variable transmission, CVT. Located usually on the transmission casing, this sensor measures the speed of the intermediate shaft, which is vital for the optimal performance of the transmission system. Proper functioning of this sensor is critical for ensuring smooth gear transitions and overall vehicle performance. Electrical issues can manifest due to various reasons, and they are often detected through the vehicle's onboard diagnostic system, which produces DTCs that guide technicians during troubleshooting. The error description for DTC P0792 highlights the role and importance of the intermediate shaft speed sensor. This sensor is pivotal in transmitting speed data from the intermediate shaft to the powertrain control module, PCM, which uses this information to manage transmission functions efficiently. Located on the transmission casing, this sensor monitors the rotational speed of the shaft, ensuring accurate shifts and controlling engine and vehicle dynamics. Should the signal from the sensor fall outside the designated range or exhibit performance issues, it triggers the DTC, thus necessitating an inspection. Since this DTC is related to the electrical circuit, it indicates problems such as open circuits, shorts, or sensor malfunction, rather than failures within the mechanical components of the transmission. Understanding its precise location and function will help technicians resolve issues more effectively. The possible causes of DTC P0792 primarily stem from electrical circuit problems. An open circuit refers to a break in the path through which current flows, while a short circuit means an unintended pathway for the current, leading to incorrect readings from the sensor. These issues can result from wear and tear, corrosion, or faulty connections within the wiring harness associated with the intermediate shaft speed sensor. Additionally, the sensor itself may be defective, leading to inaccurate readings sent to the PCM. It's essential to thoroughly inspect the electrical connections and the sensor to pinpoint the exact cause effectively. This systematic approach ensures that all potential faults are evaluated, facilitating a more straightforward resolution. Symptoms associated with DTC P0792 typically include an illuminated check engine light on the dashboard, indicating that the vehicle's onboard diagnostic system has detected a fault. Drivers may also experience noticeable transmission performance issues such as unresponsive acceleration, erratic shifts, or inappropriate gear changes. These symptoms are indicative of improper readings from the intermediate shaft speed sensor, which interferes with the PCM's ability to control transmission operation effectively. Additionally, unexpected shifts or a sudden change in engine RPM can be a manifestation of this trouble code, significantly impacting driving comfort and performance. Recognizing these symptoms early can prevent further damage and facilitate timely repairs. In the first troubleshooting step for DTC P0792, begin by turning the ignition switch to on, which activates the vehicle's electrical systems but does not crank the engine. If the vehicle is equipped with a start-stop button, press it to enter the on mode. Next, use the Honda Diagnostic System, HDS, to clear the DTC from the system. Clearing the code is essential for refreshing the ECU's data. allowing you to perform new tests without historical data influencing the results. After clearing the DTC, safely raise the vehicle on a lift and ensure that it is securely supported, allowing all four wheels to rotate freely. This preparation is crucial for the next steps of troubleshooting, as it facilitates accurate measurement and observation of the vehicle's behavior under specific conditions. The next troubleshooting step involves starting the engine and disabling the Vehicle Stability Assist (VSA) by pressing the VSA off button. This is important as the VSA may introduce varying dynamics that could affect the vehicle's speed and sensor readings. Set the shift lever to D and run the vehicle, maintaining a speed over 19 miles per hour, 30 kilometers per hour for at least 30 seconds. This period of operation helps to replicate the conditions under which the DTC was initially generated. After reaching the specified conditions, slow down and stop the vehicle to prepare for the next check. This step is vital for allowing the vehicle systems to recalibrate and ensuring that any intermittent faults may surface while monitoring sensor responses during the drive. Following the on-road testing, the third troubleshooting step requires checking for pending or confirmed DTCs using the HDS. This diagnostic scan provides insight into whether DTC P0792 is still indicated after performing the prior tests. If the code is confirmed, this indicates that the issue has indeed duplicated, and you should proceed to the next diagnostic step. However, if the code does not reappear, it could suggest an intermittent fault, meaning the system may temporarily be functioning correctly. In such a scenario, reviewing and attempting to reproduce the failure under the same conditions recorded in the freeze data or onboard snapshot is essential. This examination helps to establish a consistent troubleshooting path for intermittent issues, potentially leading to the resolution of the underlying problem. In the fourth step, focus on checking the CVT drive pulley speed sensor. Begin by rotating the front wheels with the shift lever in the D position. Use the HDS to compare the torque converter turbine speed and the input shaft drive pulley speed RPM found in the data list. These speeds should be in harmony. Otherwise, it indicates a potential malfunction in the speed sensor. When evaluating the speeds, achieve consistency among these readings to ensure that they align within expected parameters. If they are approximately the same, it signifies that the CVT drive pulley speed sensor is functioning properly. If the speeds significantly differ, this may indicate a faulty sensor requiring replacement, setting the stage for the next step in troubleshooting. When the CVT drive pulley speed sensor is determined to be functioning correctly, it is advisable to check whether the PCM or powertrain control module has the latest software installed. An outdated PCM can lead to incorrect operational parameters being implemented, which might mimic faults in the electrical circuitry. Updating the PCM ensures that all necessary patches and updates are applied, optimizing its performance. If the DTC P0792 disappears post-update, the troubleshooting process is considered complete, confirming that the previous code was due to software discrepancies. If the issue persists, substituting the original PCM with a known good unit is the next logical step. By making this substitution, technicians can determine if the original PCM is defective, necessitating its replacement and concluding the diagnostic process. In the final troubleshooting step, if the CVT drive pulley speed sensor is found faulty, it should be replaced promptly. This ensures that the sensor can accurately measure the intermediate shaft speed, allowing the transmission to perform optimally. Following the replacement, it is essential to recheck for any DTCs using the HDS diagnostic tool. Confirming that DTC P0792 no longer appears verifies that the sensor replacement resolved the issue. This systematic approach reinforces the significance of each step in isolating the problem and ensuring that all components function harmoniously. Achieving a clear diagnostic status signifies successful troubleshooting and optimally functioning vehicle systems. Final repair verification is critical for ensuring that the DTC P0792 issue has been effectively resolved. To confirm successful repair, check the overall performance of the vehicle, paying close attention to transmission behavior, responsiveness, and engine performance. Also, use the HDS to ensure that no DTCs are present in the system following repairs. This step verifies that the entire vehicle system operates without error codes surfacing, indicating a successful resolution. Additionally, conducting a thorough road test allows technicians to observe vehicle performance and confirm that everything is functioning normally under real-world conditions. This validation process is vital in providing assurance of a complete and effective repair. Preventive maintenance is essential in avoiding future occurrences of DTC P0792. Regular inspections of wiring associated with the intermediate shaft speed sensor will help identify potential wear, corrosion, or damage early on, preventing more significant issues down the road. Furthermore, keeping the PCM software up to date ensures that any improvements or required adjustments are implemented effectively, allowing the vehicle to operate optimally. Regular monitoring of vehicle performance through driving observations or periodic diagnostics can also help detect issues before they lead to operational failures. By implementing these preventive measures, owners can maintain their vehicle's health, significantly extending its lifespan while enhancing reliability. In conclusion, DTC P0792 points to an electrical circuit issue related to the intermediate shaft speed sensor A in the Honda Civic models from 2011 to 2015. Recognizing the symptoms and understanding the sensor's crucial roles aids in effectively diagnosing the problem. The troubleshooting process is methodical, addressing potential causes and verifying repairs to ensure functionality. Emphasizing preventive maintenance practices such as regular checks on the wiring and maintaining updated software on the PCM can greatly reduce the likelihood of recurring issues. Ultimately, consistent monitoring of vehicle performance plays a vital role in identifying and resolving problems promptly, ensuring smooth and reliable operation. Please like and subscribe to the channel. See you next time.